Now we come towards angular momentum. Now, like linear momentum means the momentum in straight line, that is the product of mass and velocity gives the value of linear momentum. Its unit is the same as that of mass and that of velocity, that is kilogram into meter per second. But now when we use the term angular momentum, before that, you must understand that the linear momentum P is calculated by function m into v. But when we use angular momentum, it means that the force is applied on the body in such a way that now it is indicating angular displacement. So angular momentum is represented by L and it is given by function I omega, where I stands for the moment of inertia and omega is V over R. So we can say that angular momentum L is equal to I omega, where I is the moment of inertia, which is mr square, and omega will be V over R. So one of the value of R will cancel off, and the net result for the angular momentum will become mvr. Now in mvr, mv will be linear momentum and R is the radius of rotation. So linear momentum is indicated by drawing a tangent on the circular path, and R is the radius, and linear momentum and radius are inclined at 90 degrees to each other. So these are some facts about the angular momentum, and another fact is given in the context. So the angular momentum of a particle about an axis of rotation is the product of its linear momentum and the perpendicular distance. This is what I have explained earlier. So distance of the line of action of the linear momentum from the axis of rotation. As I have earlier explained, that angular momentum is represented by L and its equation is either I omega or it will be mvr. Therefore, angular momentum is equal to linear momentum multiplied by perpendicular distance from the axis of rotation. So, if we wanted to write the SI unit, we have to compute the unit of momentum and the unit of perpendicular distance. So, dimensional equation will become ml2t minus 1. So, if we consider the Planck's constant, its unit is joule second. If we take angular momentum, it is also joule seconds, that is work into time. Now, angular momentum and Planck's constant have the same units, so they have same dimensional equation. Planck's constant we normally use in the quantum mechanics, that is the energy of photon is taken as h nu or hc over lambda. Now, next thing is the vector form of the angular momentum is given as the vector angular momentum is the cross product of R and P and the three rectangular components of the angular momentum are as given. So one of them is angular momentum along x-axis, that is taken as ypz minus zpy. Similarly, we can have the angular momentum along y-axis, that is zpx minus xpz. And similarly, angular momentum along z-axis, that is lz, that is equal to xpy minus ypx, where x, y, and z are the axes or the lattices. Now, we have to go through with the torque and angular momentum. That is the relation between torque and the angular momentum. Well, when we use this term torque, we are referring to force multiplied by perpendicular distance from the axis of rotation, and angular momentum means that is L and that is equal to I omega. I will be mr square and omega will be V over R. The net expression for the angular momentum will become mvr. mv is the linear momentum and r is the radius of rotation. So linear momentum is indicated by a tangent drawn at a point on the circular path, and r is the radius of rotation. So mv and r will be perpendicular. So angular momentum is the product of linear momentum and the radius of rotation. And torque is force into perpendicular distance. When we use the term force, means which causes the angular displacement. Now, the context is the total torque acting on a system is equal to the vector sum of the external torques acting on all the particles of the system. That is, if there are n particles, then in that case, we have to estimate the total torque. So, total torque acting on a system. System means a rigid body and it has got plenty of particles and it is equal to the vector sum of external torques acting on all the particles of the system. Also, the total angular momentum of a system of particles about a fixed point is equal to vector sum of angular momentums of all the individual particles of the system about the same point. So we have represented it mathematically, that is total angular momentum must be the vector sum of L1, L2, L3 and so on up to n, where Ln means the angular momentum of the nth particle. Wherever we are using the angular momentum, it is very clear that it should be mvr or it should be I omega, where omega is the angular speed. The rate of change of total angular momentum of a system can only be due to the torques exerted by external forces on the particles. So we have taken a derivative that is d over dt of L total. So derivative of the total angular momentum with respect to time, and that is equivalent to the total external torque. Moreover, one more thing is very important, like there is a law that is the conservation of angular momentum in linear case. We say that in case of linear momentum, the total momentum of the system is conserved when no external forces are acting. And similarly for angular momentum, the conservation laws are valid. That is, total angular momentum of the system remains constant when there are no external torque forces. Now, rate of change of angular momentum of a system of particles about a fixed point is equal to the total external torque acting on the system about the same point. Now, conservation of angular momentum. As just now I have explained, the conservation of angular momentum, that is total angular momentum, will remain constant when no external forces causing torque will be applicable. So the statement is, we know that if there are no external forces, then the total angular momentum of system of n particles is constant. And this can be written in a mathematical form, that is F external must be equal to 0 or the total torque that is equal to 0 and that is a constant vector. That is L total is constant vector. Now we say that for an isolated system, that is where there is no disturbance, with no external forces acting, both the total momentum, we are referring to linear momentum, and the total angular momentum, that is body rotating, are conserved. And this is what known as the law of conservation of angular momentum. So conservation laws are valid for angular momentum as well as linear momentum.